Okay, so in this video, we will discuss a specific Z application in the context of operation supply chain management. So far, we have talked about the statistical side of how to capture Z, how it connects to the empirical rule, a very basic application of Z in the context of how to calculate the Z-score if you know the probability, how to calculate the probability under the curve if you know the Z-score, and so on and so forth. Let's put that in the spin of something that is critical to operations, which is managing vendors or managing suppliers. Okay, so when I use the term vendor, I'm also meaning the supplier. It's kind of synonymous. Okay, so there are two things that I want to discuss here, and hopefully you'll find this discussion interesting. As much as the mathematics is there, it's also the intuitive side of understanding the business. So one is the idea of selecting suppliers. Okay, and so that is one piece of the puzzle. And then once that selection is done, how do you manage those suppliers? And so we'll talk about both of those areas in bits and pieces, and hopefully you'll be able to see some of the very basic applications of the concepts that you have learned so far in this module. So there are multiple vendors, let's say, that you are doing business with. Okay, and so these vendors, vendor 1 or supplier 1 and supplier 2, are both your current suppliers. Okay, and imagine that they are both suppliers for the same part or the same commodity. And so this process is oftentimes called multiple sourcing. Okay, or in this example, it would be dual sourcing. So suppose we are sourcing the same part or component from two different suppliers. Okay, so what happens is, even before the relationship was started, the contract was signed with the supplier, you go about trying to choose the supplier, right? You go about trying to evaluate and select those suppliers. So during that evaluation process, you had already reached out and said that I want to do business with the supplier only if you can deliver the product within X number of days. Okay, let's suppose that is mu. Okay, the average delivery time for the suppliers. That's what is shown in a request for quote or an RFQ, right? It's one of the elements that goes out when you are trying to figure out which suppliers will match. And most suppliers will come back to you and say, oh yes, we will meet this. And then you do a lengthy process of evaluating suppliers, and imagine that you have come up with these two suppliers. Okay, and you have been doing business with them, and so they are both able to meet your average delivery time. Okay, from the point the order is placed to the point the actual order is received by the customer, which is you. Okay, and therefore that's what you see here, mu1 equals mu2, which basically means both these suppliers have the same average time to deliver, or else they wouldn't be in business. However, if you look at their delivery pattern, okay, and so this is your distribution of delivery time. Okay, and so every time the supplier delivers to you, the delivery time, the amount of time the supplier took to deliver, is recorded. And so if you log in all of those data points and you fit that into distributions, this is what you see. And so therefore the question therefore becomes, who do you do business with going forward? Do you continue with both? Does one have to improve? Is one doing better than the other? And that's where that basic concept of how the shape of a distribution is connected to sigma comes into play. Okay, if you look at these two suppliers, in essence, while the average of both those suppliers or the mean remains the same, it is very clear that one of these suppliers has a very high variability in their delivery time pattern. As opposed to that, this other supplier here has a much lower variability and therefore a much better confidence that they will deliver within that prescribed average. If I had to choose between these two suppliers, I would always choose this guy, because this supplier has a much narrower distribution, which is closer to the mean. It's leaner, which basically means that the average that you are seeing is a more truer average compared to the other one that is way flat. And this is the very basic idea that we talked about. If this guy has a sigma of sigma 1 and this guy has a sigma of sigma 2, you can right away say that sigma 2 is much greater than sigma 1. You don't want sigma to be high. You want sigma to be low. That is the whole idea of variance reduction. And so that happens in every step of the puzzle. Okay? So before I move on to the next piece of the puzzle, I want to bring in a couple of core concepts that lies within vendor selection and vendor management. Okay, so the first concept is about managing vendors. Okay, so when I'm talking about managing vendors, if a certain vendor or a certain supplier has this kind of a distribution, that really doesn't look good. Okay, in essence, you would want that supplier to have this kind of a distribution. We talked about it. We are trying to reduce that sigma 2 to a sigma 1, which is what we are trying to get out of this shape. Now the question is, what do you do with this supplier? Okay, the one that has such a high sigma, such a high variability. There are two ways to deal with them. One is just say, I'm done with doing business with you, I'll find somebody else. That had been the motto of most companies, especially American companies, for a long period of time, for a greater part of the last 5 decades. But as painstakingly the American companies figured out, that way of doing business doesn't build relationships. That way of doing business doesn't build partnerships. That way of doing business doesn't build harmony, especially at times when you need the supplier to have your back and support you. And so they opted for the old Japanese model, which is basically saying that you don't stop doing business with suppliers. You build them. You get them up to your level of expectation. And so that is where the idea of improving a supplier started. How can you improve the supplier and improve the supplier's variability from a sigma 2 to a sigma 1 so that the supplier's overall delivery pattern looks something like this, as opposed to a very, very wide delivery distribution. Okay, how can you work with the supplier to improve them? This is where engineers are strategically placed within the supplier's domain. Oftentimes there's a lot of to and fro travel between suppliers and manufacturers to ensure that both parties understand expectations clearly. Sometimes there are shared governances, sometimes there are shared technology, shared infrastructure, and so on and so forth. All of that in trying to attend this aspect of the supplier, trying to improve the supplier. So that is what managing vendors is about. So that is one piece of the puzzle. The other piece of the puzzle is what I define as delivery window. Okay, so we are all exposed to this. If you order a product from Amazon, let's say, okay, if the product is available in Amazon's warehouse, if you choose Prime, then probably it becomes a 2-day or a next day delivery. But the next day delivery is possible only when the product is actually available at Amazon's warehouse. Sometimes you use a third party, so it becomes a customer to customer or a customer to business transaction where Amazon becomes the third party. Okay, and Amazon now has to procure the product from the customer or the other business and then get the product to the recipient. That takes time. Depends on where the product is, how much time it takes to travel to Amazon. And so when you place the order through Amazon, Amazon will tell you 7 to 10 business days. Okay, sometimes it can give you a bigger window of delivery. The reason why companies design delivery windows is because it allows them to buy the risk. If I tell a customer that you'll get the product delivered 5 days from now, exactly on the 5th day, okay, and 5th day goes and nothing comes, on the 6th day the product is delivered, you know what has just happened? I have missed my service guarantee, and the customer has already written a bad review for me, and social media has ensured that the review has spread like wildfire. How do I hedge my risk? Instead of saying that I'll get the product delivered by the 5th day, I'll say we'll get the product delivered between 4 to 7 days. Bingo. Suddenly, if I deliver it on the 4th day, I'm safe. On the 7th day, I'm safe, because the customer has already made that decision and psychological change in their mindset that as long as the product gets delivered between 4 and 7 days, it is on time. Okay, so that's the context of delivering on time. And it's the same thing that happens within supply chains. Within supply chains, you have a manufacturer who is actually getting a part from a supplier. And unless the part arrives, the manufacturer cannot run the assembly line. Guess what? There has to be some level of accountability, and that accountability is built by developing a delivery window within which the supplier has to deliver the product to the manufacturer. Walmart manages this as a fixed 4-day delivery window. Okay, and for certain suppliers, they have even brought this down to 2 days. Because it's a tremendous competitive advantage for many of these companies. The earlier they get the part, the faster the product moves through the system, the faster the turnover is, and the more money the entire supply chain makes. And so they stick to their guns. They are very clearly written in the contract, and if there is a breach in contract, the supplier pays a penalty cost. Okay, so that's the idea of a delivery window, and as long as the supplier delivers within the window, the delivery is considered on time. You may have come across this acronym called OTD. It is one of the most famous performance metrics within the supply chain world, and OTD stands for on-time delivery. It's essentially the portion of time within this 4 and 7 days that the supplier delivers. As long as the supplier is delivering on time, that is the on-time delivery that has been calculated. So with this backdrop, let's go into trying to improve a supplier and see how that works. So when you look into a delivery window, let's suppose a delivery window has been defined as on time between 19 and 24 days. Okay, the normal distribution, mu of 22 days for a certain supplier. Okay, so in this case, we are not looking into two suppliers. Okay, all we are looking at is a before and an after scenario. That's all we are looking at. So the idea, as I had mentioned in the previous slide, is when you are managing vendors, you are trying to convert the supplier from that kind of a distribution to a more narrow, lean distribution. And that's essentially what you're looking at. This is the initial stage of the supplier. Okay, so the supplier is already doing business with you. The mean delivery time is 22. You are slapping a certain window of delivery within which the supplier has to deliver. Okay, and that window goes from 19 to 24 days, which basically makes this entire zone your on-time delivery area. Okay, anywhere outside of here and the supplier is penalized. Why? Because in this case the supplier is delivering early. Sometimes the supplier basically does this on purpose because they have extremely high holding costs of inventory, and so they would rather pay the penalty cost to the manufacturer and deliver early. When the supplier delivers early, the manufacturer now has to hold the supplier's inventory and there is warehousing costs involved. And therefore, the supplier is charged a penalty cost. If the supplier is late, that penalty cost is much higher, because now that is impacting the overall supply chain and the delivery to the customer. And the manufacturer now has to expedite the process, and expediting routes are almost always more expensive, which is why late deliveries are an absolute no-no. And that's where suppliers are penalized a lot. As long as the supplier delivers between 19 and 24 days, life is good. So the first scenario is where the supplier has a distribution that goes like this. You have 22 as your mean. You have a standard deviation of 1.8, which basically defines that specific shape of the distribution. I have slapped a delivery window of between 19 to 24 days on the supplier. What I am after is trying to figure out what is the probability of an on-time delivery. That's what I'm after. Okay? And if you are able to apply what you have learned in the previous slides, you will be able to find the specific answer. Okay? It's actually pretty easy. If you break this up, I'll show one, hopefully the other will make sense to you. Okay? If you look at this as your mean, this as your standard deviation, and this point on the distribution, okay, which is 19. Okay, one more time, recall, any point x on the distribution is z standard deviations away from the mean. That's what we have learned. So in this context, your 19 basically is your x, the point on the distribution. Your mean 22, 1.8 is your sigma. 3 knowns, 1 unknown, right? So if you draw the corresponding z distribution, of course this point here is 0 because that's the corresponding z value to your mean of 22, but if you drag this down, you find a negative z value for this point of 19, right? If you do the calculations. And once you find that negative z value, if you look up your z table, you are able to calculate what that area is, right? And then what you do is you look at the other end of the puzzle, which is 22. So you have 24 here, which is the other end of the spectrum, right? So this is what you are after, your on-time delivery. But to get there, here is your 24. It's the same story, right? So 24 now becomes your x. Your mu is still 22. Your sigma is still 1.8. So if you look at the corresponding z value, now you'll have a positive z value, right? And then when you look at the positive z value and you look up the z table, you'll find this entire area to the left of z, right? But you are not after this entire area. You are only after this small area between 19 and 24. So what do? You take this entire area, right? And then subtract from there this small area. And what is left behind is essentially your on-time delivery. And when you do that calculation, you'll find this to be the answer. And whatever I just said, you repeat that entire process, only this time change the sigma from 1.8 to 1.3. In other words, you reduce the sigma from 1.8 to 1.3. That's a reduction of 0.5 days, which is half a day, which is 12 hours. And what will happen is 22 doesn't change, 19 doesn't change, 24 doesn't change. My delivery window is untouched. All you have done is you have made this guy 1.3. Guess what? You'll have a curve that goes like this. Nothing else being changed, you now have so much of more area within those two domains. And that's essentially what is happening here. Just by being able to reduce sigma, which is what you're doing here, you are able to increase your on-time delivery from 81.8% to 92.7%. That is a more than 10% increase. This is real data. I actually worked on a pharmaceutical data set many years back, and this is a small piece of the data set. That's the power of Z, something as simple as that. And if you recall some of the previous examples that I had shared with you, especially when we are looking into the Z distribution examples, this number 5 that you look at, the probability that Z takes a value between a negative number and a positive number, that approach is the same exact approach that we are doing here. It's the same exact approach, because the raw data here, when this raw data gets transferred into a corresponding Z distribution, this 19 turns into a negative Z value, the 24 turns into a positive Z value. And all you're trying to figure out is this area between those two Z values. The same exact application of number 5 that you saw in that other slide. That's it, my friends. That's how a very simple concept like Z is applied on an everyday basis to make operational decisions, to improve supplier relationships, to work with suppliers, improve them, and continue the partnership and build what we define as supplier relationship management.